So the first time I'm using a plug instead of the computer for the sun tracking. So you just have the control box, you plug it in, and then it automatically follows the sun. So I'm going to be testing this today and comparing the temperature with sun tracking and without sun tracking. Alright, so I'm warming up the pipe here to start. And I just have this piece here to prop it up. So in the beginning I'm just going to run it without sun tracking. So I'm going to see, as the sun tracks, I'm going to see how quickly it loses the target and how it cools down. And then I'm going to run it for a couple hours with sun tracking to show that the heat is maintained because the computer corrects for the location of the sun. So the temperature is dropping really fast now without sun tracking. So it started at over 100 and now it's at 82, 81. So it's dropping so fast. In the last couple minutes it's dropped almost 10 degrees. So this is what's happening now, is that you can see the shadow here. See, one sensor is exposed and the shadow isn't directly under the pipe. So when the light comes and it hits the mirror, it's off center, so the light misses it. So you see a lot of light underneath here. So that's all the missed light. So that's not hitting the pipe anymore. And that's why it's losing power. So once this gets a little bit more off target, I'm going to add the sun tracking. You'll see how it maintains the temperature now because it stays on target. Alright, so this is completely off target now without sun tracking. The sun's missing the pipe. Without a mirror like the tinfoil, this pipe could probably get around 50 degrees just as the pipe sitting outside with sun. So very little reflected light is hitting this pipe right now. It's only at 57 degrees. And you can see the shadow is significantly lower. It's not lined up. It's supposed to be where that sensor is. The sensor is completely uncovered. So the sun tracking will make sure that when that sensor gets light, it runs the motors and puts it back on target. So I'm going to switch now to the sun tracking. So now I'm switching over to sun tracking. I have the sensors connected, everything else. I have the drive rubber band there. So now you can see that there's sun on this side, but there's no sun on that side. So when I plug in the controller here, what should happen is it should tell the motor to angle into the sun, and it's going to turn until this one starts getting sun. So let's see. See how that works. I plugged it in, it rotates, and it's aimed directly into the sun. Perfect. So now we're going to let this heat up. Alright, so the sun tracking just aimed it in the sun. It was at 45 degrees, and now it's quickly increasing. So this is the difference between aiming the mirror at the sun and not aiming the mirror at the sun. So this would have sat at 45 degrees forever, but now the motor kicked in, the sensor is pointed directly in the sun, and it's climbing very fast. Now, as you can see here, both sensors are in shadow on both sides. So that's what I want. So as the sun climbs in the sky, as it's going from east to west, this sensor here is going to get a little bit more sun. The motor's going to turn on just for a second to put it back on target, and it's going to stay warm. So as we've been talking, it went from 45 and now it's 66. So it's climbing very fast. So 110 degrees, 111, wow, really getting hot. So when this stabilizes, I'm going to start recording, and then we're going to see how this adjusts and stays hot instead of losing target like the other test. Alright, so the model's already corrected. You can see that there's quite a bit of a gap here for the sensor, and here it's just about to touch the bottom one. So it's moved just that little bit, and that made a big difference in the temperatures. It's at 119 now. So it's the highest temperature it's been so far. So it's always tough to catch these things, because I'm basically just leaving this outside by itself, and I just come outside to check the temperatures every now and then. So it just happens for a split second, readjusts, and then it just sits there. Alright, so the sun tracking model is still doing very well. It's at 122. Now, even though if you have a straight line, it's supposed to be perpendicular. The sun is supposed to be perpendicular to the model, and it's off by maybe 30 degrees. So you can see that the shadow is off on an angle. It should be straight back, because then you have the maximum amount of sun that's coming in. If you have an angle, then this is actually smaller. The projected area is smaller, so you get less power. So if we're driving the solar car, obviously we can only rotate in one axis, so the sun is going to be all over the place. So sometimes if the angle is wrong, we're going to get less power. We can only rotate like this. But if we're going to stop and charge, we can always just take the model, the trailer, and rotate it. So we could take the car and we could drive this way and it would pivot about the wheels, and we can get it until it's perpendicular to the sun to get the most power and charge the car the fastest. So it's not pointed perpendicular in the sun, and this angle is getting too great. So I want to do some testing where I just rotate the base and then have the sun tracking in the other axis. So actually when I rotate this, you can see that it's going to move. As I rotate here, make sure I get everything. So I want the shadow to be quite square, which is just about right there. And it's, again, right on target again. Very well done. Alright, so we're really heated up now that I've pointed it perpendicular to the sun. It's at 127 degrees. It's very hot. But yeah, the sun tracking is just working amazing. I've been testing for something like 4 hours, and all I do, I just go inside and I let it sun track by itself. So it's very low maintenance. That's what it's supposed to do. It's supposed to create energy passively, automatically, and you don't have to do anything. Okay, so here for the sun tracking. This is without sun tracking, so you see as the sun moves, it loses the target, and a lot of the heat from the pipe is lost, and it goes all the way down to as hot as the pipe would be if it didn't have any focusing of the light. And this one here shows with the sun tracking. So the sun moves, and then the sun tracking motor kicks on, and it readjusts it on target, so it stays at a very high temperature, and it doesn't lose all its heat. The next one here just shows that we kept the sun tracking on over time for 3 hours, and it stayed about at 120 degrees the whole time. So without sun tracking, it would have dropped very quickly.